start the recording here and then we can get started. We tried to be more proactive. Oh, yeah, it's already recording. We tried to be more proactive this time around to advertise the agenda ahead of time and make sure the agenda actually has relevant items. So the leads are taking a more active role in making sure this is a productive discussion. So want to continue doing that in the future. If there's anything, suggestions that people have or whatever, as far as things that we can do to improve the value of this discussion every month, let us know. All right, so I'll put the agenda in the chat if anybody hasn't seen it already. Boom, and the first item is the RBD cloud migration feature. So, go ahead, Jason.
All right, so just for some background, RBD mirroring was added to Ceph back in the Joule release. It had been a feature that had been on the Ceph backlog for a long time. So the model that we used when implementing RBD mirroring was to, number one, keep it as simple and as easy to implement as possible, but also we wanted to make sure that all the replication was consistent, I/O consistent. So that kind of drove two design considerations. One was the need to have a journal that would record all I/O in a consistent order, and that was what would be used to process the mirroring of data across the wire. And also the other design choice being that we wanted to just reuse as much as possible. So we reused basically Librados to connect clusters together. That meant that you had to have, between your two clusters, you had to have a fully routable network so that the two clusters could talk to each other. And so after the Joule release, from our point of view, everything was fine. But I think in reality, it just turns out not a lot of people have been using the feature. And over the past couple of releases, it's gotten more and more apparent interest in RBD mirroring, and also the current issues with it. So the journaling issue being it's going to hit you with it's going to cause twice as many IOs going to your storage system as without journaling, and as a result, because it needs to write to the journal first, wait for the journal to be committed before it can actually go modify the backend RBD image. It also doubles your latency for IO. And then the routable network issue, because we use Librados from two instances of Librados to talk to two different clusters from the RBD mirror daemon. Some people find it awkward or hard to have two fully routable Ceph cluster networks over a WAN connection. So going forward, as we try to embrace more of this hybrid cloud style model of Ceph storage, we want to be able to offer new modes of actually being able to mirror your RBD images to different data centers or clusters or clouds or whatever you want to call it, and hopefully a way that is higher performance, perhaps better able to suit some other use cases besides the fully consistent journal-based model. So what I'm offering, or what I'm proposing going forward for Octopus is, number one, we'll keep the current system as is, but we'll expand it by offering a couple other optional mirroring modes. One of them being a periodic schedule-based automatic snapshot. We'll have some background process, RBD mirror daemon, take snapshots on images on a schedule, whatever the user defines, and we'll use those snapshots, and we'll use diff replication between the previous snapshot and the current head snapshot just to push the deltas to the other side. If you have a 1 hour schedule where you want to push changes every hour or whatever, that you're only pushing changes for up to that 1 hour period. And because it's a snapshot, it should still be crash consistent. We just need to make sure that when we're replicating the snapshot, and if you have a failure during that transmission, that you can roll back to the previous last known good consistent state, because you were only consistent at the actual snapshot point. And then besides the periodic, maybe just offer a way to say on demand. If you have a cloud workload, I'm running some workload X on this cluster, I want to on demand move it to a different cluster. I just want to be able to tell Ceph, hey, start migrating this image from this Ceph cluster to this other Ceph cluster elsewhere. And one of the ways we can also offer that in a way that speeds up this transition process is to kind of also extend the live migration feature that was added, the RBD image live migration feature that was added in the Nautilus release, offer kind of a form of inter-cluster live migration, where all reads or writes would be satisfied by pulling the data from the remote cluster if it doesn't already exist, if that given backing object hasn't already been deeply copied to the remote or to the current local cluster. So that's some options of how we can eliminate or kind of offload the current performance hit from journaling. The other big issue with RBD mirroring is the networking and how to connect two different clusters together that are over a WAN. So back when we first were talking about and designing the original Joule implementation of RBD mirroring, one of the things we talked about was, well, in the future we could add this capability, which is kind of like the concept of a Rados proxy, where you'd run this proxy on both sides, cluster A, cluster B. These proxies would basically connect to each other, but any local services connecting to that proxy would get a faked out MON map and OSD map that would basically tell it, hey, all your connections to this cluster over here are actually through this proxy, this local proxy, and it would tunnel the traffic through the other side, and the other side would then ban it back out to the OSDs and the MONs on the other side as needed. So that would eliminate the need to have a fully routable network between two clusters. You can kind of tunnel that traffic through a single TCP connection. One of the downsides with that approach is that you still have the issue. It makes it super easy for us. I mean, assuming we get the Rados proxy, RBD mirror doesn't need to change at all. We can keep using our low-level Rados fundamentals of, hey, watch an image, read from objects, to read from journals, or to read snapshot entries or whatever. The other design choice we made when we implemented RBD mirroring, just in the sake of time and make simplicity, was that we had a pull model where it's the remote side that's pulling changes from the source primary image and applying it locally. But if you have any latency on that WAN link, that pull process becomes more and more and more expensive, because those pull operations are handled on individual Rados objects. They're not handled in batch. So one of the other alternatives we could think about is kind of swapping the roles around and having RBD mirror or some other thing in the middle operate as a push process. It locally watches for changes, gathers them up in a batch, and can ship those batches off to the other side, and the other side can apply them in bulk. So you don't have that like constant polling operation that we're dealing with right now. You don't have to have the same issues of high latency links. So those are things we want to think about on the RBD team for Octopus. And then I wrote some future ideas to also think about going forward. Like, I know Azure supports a REST API where you can just get access to their blob image storage. So it creates we could have some simple tooling to import or export to Azure. And then during Cephlacon, I also talked to a couple people about the idea of having a RGW expose like a pseudo bucket for multi-site RGW replication that would expose RBD image snapshots, and a multi-site could actually take those snapshots and properly replicate them across. But it wouldn't involve, because it's a pseudo bucket, RGW would actually be using librd to like actually see the data. It wouldn't actually have to be copying the whole like snapshots as objects within RGW. So that's the. Oh, sorry, go ahead.
as I mentioned, that the RGW pseudo bucket thing aligns well with the changes that the RGW team is discussing about abstracting the way that buckets are stored, persisted, so that you could have a backend that passes things through to an external cloud or to RBD or to libceffs or something else. Um, so they probably need to get a little bit further down the road before that makes sense.
Yeah, that's why I put it in the future work category.
Yeah.
Yeah,
Yep.
talking to Casey, he was talking about how those design plans and trying to
Okay.
rip out some of the Rados fundamentals out of the core logic.
I have a couple questions on the mirroring modes. So so the first one is the mode that happens today, which I gather is a whole model. So
Yeah,
the
so old
RBD
model,
mirror daemon modes.
and we'll continue to use the journal model. We have I know Makola Suze he's working on improvements. We had to make some compromises when we did it because like we used to only support a single RBD mirror daemon, and if someone created 1,000 images, we couldn't have 2 terabytes of memory being used for caching all those journal objects. We support active now, so we can split the load, and now we're integrating basically a memory pool that says, all right, you have a target allocation for this RBD memory daemon of 2 gigabytes or whatever you set for it. And if you only have 5 images to mirror, it'll try to use as much memory as possible so it can prefetch more objects and basically run faster. Instead of taking small nibbles of journal objects, we can take big gulps of the journal objects to try to reduce that latency from all those pull effects.
So for the second mode, the snapshot diff replication, um, is the idea that the existing RBD mirror daemon would drive that too, or would this be a
Yes.
totally okay?
No, yeah. The goal would be it's RBD mirror daemon. We don't need it. We already have it running. We already have the concept of leaders and things like that.
Right.
So the leader can be responsible for coordinating the creation of snapshots, on the defined schedule, whatever those defined schedules are. I think there will be some overlap, I know, with the Ceph talk or version of schedule-based snapshot. So I think a consistent way to define those schedules would be a key.
Yeah, and we don't. I mean, there isn't anything right now that lets you set RBD snapshot schedules either.
No,
Right?
yeah, no.
Yeah. Okay. Okay. So
And these would be so we have snapshot namespaces. So these would be snapshots that would be basically owned by the RBD mirroring process. If you do a snapshot LS, you won't see them. Delete the image, and it has mirroring snapshots associated with it. They get auto deleted, so the user doesn't have to care about them. And that way we can actually make sure, like, well, what if you set it to replicate every hour and it takes longer than an hour to, create a new snapshot? We don't want to create a new snapshot if you're still replicating the last one. So it can control the life cycles of those.
Yep. Yeah. One of the things that came up when we were thinking about the SFS one also is if you set up this relationship that you want to mirror your image and the user creates a snapshot, should that user snapshot also be mirrored? Doesn't matter, of course, in addition to the automated checkpoint ones. Which I think the answer is probably yes, but okay.
Yeah, so well, for the purposes of mirroring, we try to keep the images consistent. So we would still, I think, have to take those snapshots as well, regardless.
Yeah, exactly.
Otherwise, the images start to diverge.
Yeah. Yep. With the flows for like when you do like a failover and fail back with the mode one, would that map onto the snapshot mirroring thing also? Be a different set of.
In theory, it could, because if you have the concept of the live migration tied into it,
Yeah.
as long as it's able to pull the latest data from remote, you could still use that model. Like basically, create a snapshot at head, start the live migration, and basically attach it to the head snapshot on the remote side. So while it's actually copying the data in the background, it also, if on demand as your librd client needs data, it can pull it live from the other side. Basically, copy it up so you don't have to read it once from the remote side per backing object. At the worst case.
So I mean, I think the snapshot thing makes sense to me conceptually. That the on-demand part, if does that mean that the librd has to be able, like, say you do this live migration, but the actual data hasn't been copied yet, and you do a read on the remote side? Is it supposed to? Is there
So
some proxy on, or is it the?
so that's the live migration part, right? Where it's basically on demand. Like I shot this image, basically I stopped the workload on cluster A, and
Okay.
I basically attach a live migration on cluster B, saying, hey, you're attached to this image on cluster A. I can restart my workload instantly or near instantaneously against
Mhm.
cluster B, and as needed, it can pull the data from the
But
remote side.
the it in this case is the librd client also reading from cluster A when it needs to, or is
Yes,
there some? I
yes,
see.
yes.
Okay, got it. Okay,
So you would still have RBD mirror trying to think it in the background, but on demand.
it could
The,
also do it.
the live migration process says, hey, I'm missing data for this backing object. I'm just going to go and get it from that remote cluster because I know all the details how to connect to that remote cluster.
Got it. Okay. Okay. I assume that we'll start with two and then do three.
Yeah.
Okay.
Well, probably start with three because I think two is an add-on to, because if two is still based on live migrations, like the data, you can instantly get the data and use the image on the remote side. Um, you are missing then is just the process to create snapshots.
Okay.
So regarding snapshot creation, if it's going to be RBD mirror that initiates the snapshot, how do we ensure consistency from the point of view of the higher level applications actually using the image? Because we need to
Yeah,
somehow
you don't get
freeze
you
and
don't get an
unfreeze.
FSF freeze. Yeah.
Yeah. So how do we do that?
That's a good question. So whether we need to build hooks into QEMU or something like that, where we could call down into QEMU, I don't know if that's even possible. Like,
I mean, does it matter? Because it it's the equivalent of like crash consistency, right? Because the librd client that's using has exclusive access is the one that enforces the time snapshot cut point, right? But does it matter? Does it matter whether you call up into the main kernel?
only if you wanted application level.
Yeah. I mean, we don't do that today, right? For normal snapshots. I'm not
Right.
sure this would be any different.
Well, we
Well,
don't, but
there's hooks
then
right now to do it, like
the
built
normal
back into Grado.
snapshots are initiated by the user who can supposedly stop the workload or freeze the file system, take the snapshot, and then unfreeze it. Here it will be an external entity it'll be
Right.
a snapshot that is initiated by Ceph as opposed to by the user. So, and I think it needs to be consistent from the point of view of a high level application because that's the point that you roll back if things go wrong, right?
I mean, I guess, but I mean, what we do today gives you crash consistency, right? So you have a literal point in time where it's as if however long ago you're resuming on the other side. So it's not, as long as your application is well behaved, it should be able to tolerate a crash. It would be nice if it, I guess, could also have a more careful timing of its snapshots, but I'm not actually sure how many applications need that.
Yeah. So like in terms of like if you're doing hooks into QEMU, we did some type of call out block driver. There's the guest FS free stuff. So I think there's already hooks with like the QEMU guest agent where QEMU can instruct the guest agent to say, hey, freeze the file system. So if you wanted to get to that level, if we provided those hooks in QEMU, there is possible.
That's something that we could do independently that would
Yes.
probably be valuable.
Yeah.
Yeah.
Yeah. It wouldn't necessarily be tied to this effort because in theory, anyone can create a snapshot at any time.
Right. Okay.
I assume there's got to be something equivalent if in the kernel as well. If the kernel saw, hey, snapshot created, it could. Right now, with exclusive lock, it's the exclusive lock owner that creates the snapshot. Except in the kernel, I think it basically says I can't do it. We could always add those hooks to say, yes, I can create that snapshot for you, and I'll freeze the file system or do whatever I need to do.
Yeah.
Can you actually call into the guest agent? My understanding was it was kind of the other way around, where like the orchestrator framework or whatever above Qemu would freeze the file system with the guest agent and then initiate the snapshot itself.
That's what like Cinder does right now, right?
Yeah.
It's all. I kind of wonder if you couldn't like somehow hook it all together.
Mm-hmm.
It is the Qemu guest agent after all.
Yeah.
I had one last question on the Rados proxy thing. It sounds like the idea is to fake out a mon map and an OSD map, so you're talking to like a virtualized on an OSD that then
Exactly,
proxies
yeah.
everything. I wonder if it would be simpler to modify the mon client and objector so that they just understood that they should communicate via proxy. And so instead of having to fake it out, the mon client would just always talk to some, the equivalent of setting an environment variable that says sox proxy equals, and your HTTP clients know what to do about it. You do something similar where we would just tunnel everything from some third entity.
They would tunnel directly to the remote side.
Yeah, I mean we can.
Yeah, because I think you run into the same problem with like now AXA or whatever are taking that long round trip. Like, I guess they would anyway.
I mean, faking a map is super easy. So what would the point be of teaching them how to tunnel?
I think that the proxy would be more complicated because you have one like objector thinks it's sending everything to one OSD, and this one OSD has to figure out how to figure out where.
Well, so in theory, you want the proxies to be able to scale out horizontally too, right? So if the proxies know about each other, they could divide up the workload and say, all right, you get 1/3, 1/nth of the OSDs, then the other side is go talk to the other side, make a match. But
yeah, and how to like request resends work when I don't know. I think it gets complicated.
Well, but I mean, if we were trying to write a proxy, then we would need to add like a whole other enveloping layer. I don't think that's easier.
Yeah, maybe not. I guess my question is the goal to make an unmodified client be able to function as if we're just talking to the proxy? Because if that's the case, then yes, I mean the only way to do it is fake out the maps. But if that isn't a requirement, if it's fine to have the client might understand that it needs to be talking to a proxy and behave differently, then there's a much wider design space that we can consider. I haven't really thought about it because I just noticed this just now, but I guess faking out the maps isn't the only option.
Yeah.
It has some other nice properties though, besides meaning like it means that you don't need to upgrade the clusters in sync for them to work well together if you're doing this mirroring, which is probably important. It just the proxy just needs to be able to handle them.
I'm not sure I get that point.
Wouldn't you have the same exact upgrade problems either way?
It's a lot easier to upgrade your proxies than like at a point than it is to upgrade two geographically separated Ceph clusters. We already have users and customers who have trouble upgrading their clients at the same time as their Ceph clusters, and if they were completely different data centers, that's a whole extra special thing. So you don't want to end up in a design space where if you upgrade one end of it, it stops working, or where you aren't allowed to enable something because the remote proxying client doesn't know how to speak a particular language.
Well, the OSD cluster must always be backwards compatible, right?
Yeah, but we
always
do a lot of feature flag enablements. So it would really be terrible. Yeah, because it's a new feature. Well, like it's an admin thing that you need to do, but like we got lots and lots of Ceph clusters out there that are still running on like Hammer or something.
Yeah, it's probably reasonable to say that they don't get to use the new features. They don't upgrade the client.
Yeah, but I mean that means that you can't have like that you can't sort of go around in circles doing the upgrades and get the new stuff in your new places.
Yeah.
Like people are going to be a lot more conservative with their backup destinations, or at least they're, some people will be more conservative with backup destinations, and some will be more conservative with their production and stuff. And,
well, they'll probably decouple the upgrades either way, right?
Yeah.
So there needs to be some level of compatibility between
and
the
that's
clients
a
and
lot
the proxy
easier.
and or the proxy and the
Yeah, but that's a lot easier when it's a proxy and not all of the Rados clients running in the cluster.
could be.
Like you can upgrade the Rados client proxy package and have it talk to both sides without. And I mean, like we had a lot of trouble just with forwarding messages within the monitors. I can't imagine like writing a whole proxy layer that worked would be awful.
Yes.
The part that worries me is that it's the Mon client, the manager client, the OSD client, and I guess it feels like this warrants its own discussion, probably on list, because is it sufficient? Is the goal just to not have 1,000 parallel TCP connections and just tunnel them over like one meta tunnel? Because semantically, that's probably what a proxy is doing, right? An OSD request is still going to pass over the wire to the OSD on the other side.
Yes.
So is that different than
the issue being the routable, fully routable networks that people.
Right. I wonder if just making them routable and tunneling them over whatever, some tunneling layer 3 protocol, whatever is it going to be that different?
Well, I mean, if you have a site, a lot of people are like, oh, my site, yeah, here my Ceph cluster is 10/16 subnet or whatever, and they do it on both sides. Like, oh, great.
Yep. Okay.
I mean, the alternate is to flip it around, and we basically come up with our own way to batch send stuff to the other side.
Yeah. Any other questions on this? I think we're going to schedule either next week or the week after a series of meetings to talk about the Octopus priorities. So presumably this will come up there. Is the next step on these to sketch out a more detailed proposal on mode 2 and mode 3, or what's?
Well, yeah. What we have right now without the Rados proxy or whatever, we can get it to work with the caveats of the routing. So yeah, the next step is the diving into the design of the new mirroring modes and how they interact with one another.
Have you thought about having some of the mirroring modes support like kind of active-active in different sites for different sets of images? Or maybe like migrating kind of certain images around the world over the course of a day?
Like follow the sun stuff?
Yeah.
So I mean, like the number 3 in theory, you could script that mode to follow the sun, right? Especially if you had a periodic that basically got you most of the way caught up, and then the final step is just like and
right. I guess
now
the question is how much maybe we can think about what we want to automate, what kind of policies we might want to have around that in the future.
Well, in terms of the high-level orchestration, again, it's like one of those problems where it's so far out of our hands that we can only provide the low-level tools of, deal with the networking, deal with moving your workloads, and all those things that are 10 layers above us.
Yeah, I mean, in the block case, you'd be like shipping a VM around the world, right? So that requires some level of coordination from Nova or Kubernetes or whatever the hell of us.
Well, yeah, if you're following the Kubernetes example, and let's say you have like a workload of 1,000 pods, each with their own independent block workloads, whatever, you kind of just like bring down some and bring them up, and start, gradually shifting the load, over to the new site. So we don't have to worry about like the service is down and then the service comes back up because you have n number of endpoints, providing the service.
All right. Any last comments on that one before we move to the next topic? All right. Thanks, Jason. The next item is this SFFS snap mirroring. First order of business is probably picking a name that isn't snap mirror because that's trademarked. So suggestion there, welcome. So the goal here is similar to the RBD mode 2 that Jason was just describing, where you have a local SFFS and another SFFS and another cluster somewhere else. You just want to specify, you want to do a DR mode where you're periodically taking snapshots on a subdirectory and then mirroring the snapshots across whatever timing. If you do it every 10 minutes, every hour, whatever, that's how stale your disaster recovery backup copy might be. I think I kind of broke this into parts because I think it's somewhat related to just specifying a snap schedule in general. It turns out that I think maybe they shouldn't actually be tightly coupled, but maybe just setting the schedule stuff would be a good place to start. So part one on the snapshot scheduling piece. The idea would just be that you, for any given subdirectory or any given file system in the cluster, any given subdirectory, you can specify a schedule that says that I want a snapshot to be taken every hour or every 2 hours or every day or every month or whatever it is. And then also have a retention policy that I want to keep the last 7 days or last 2 months or whatever it is. And then we can just have a manager module that implements that schedule. Set a CLI commands to view the schedule, what it's automatically getting snapshotted, and have something managing it. So I think probably the first thing is, just defining a CLI experience that we like. I think the only real question I ran into here is like, how do we want to specify the schedule? There are a bunch of different ways that people do it. Sometimes they say you have one sequence of snapshots that are daily and I keep n of them, and I have another sequence that are weekly and I take some other number of those. Other ways of doing it, try to like share the daily is the same as every 7th daily is also the weekly, so you don't have like a duplication of reuse of snapshots. So there are a couple different options there. And then we just have a worker that would take the snapshots on the schedule and then clean them up when we're done. Any thoughts, questions, comments on that part?
We're going to need to spend some time to figure out a language that makes sense. I've been through this 2 or 3 times, and I think I finally understand like the examples here, but the CLI that's given here is almost incomprehensible.
For the schedule?
Yeah, the numbers get used in like different sequence, like you're smushing them together, and I think I understand why now, but it's still like super weird. Whoever was yellow, apparently like Borg backups has a different syntax, but the link is broken now, so aren't a lot of examples, but that looks a little more understandable, maybe.
The idea of the Borg backup idea is to actually separate the snapshotting schedule from the pruning schedule. That would simplify the CLI quite significantly, I think, because you could, create your snapshot schedule and then create a separate pruning schedule for the same subdirectory, and the two are obviously related because you want to do some pruning on snapshotting, but you can look at them individually and specify them individually, and the only interrelation of the two is actually just a subdirectory.
I'm having a hard time wrapping my head around a way that you can describe a pruning schedule that isn't linked directly to the snapshotting schedule, because you have to know which sequence of snapshots you're pruning.
Well, what I meant to illustrate with the example of borg backup is that you basically you don't base the pruning schedule on the snapshots themselves, but on time intervals. So you basically specify, okay, I want to keep for 30 minutes, I want to keep like a schedule a snapshot every minute. I want to keep 4 weekly schedules, and then you can go and look like, okay, we have a week. Do we have one schedule snapshot in there? Yes, good. Nothing to prune. If we have 2 in there, we prune 1.
I see. Okay. It almost seems like that you could derive the snapshot schedule from the pruning schedule then, right? Because if you want n of them, I want n backups on the last day.
Right. I think that this would better interact though with a mix of scheduled snapshots and maybe user created snapshots. Like a user could create as many snapshots as they wanted, but they would still get pruned out.
I see. Okay.
And then I kind of put this in the Etherpad as well. You could conceivably think about having multiple schedules per subdirectory. I've had this wacky example. Who knows what kind of requirements some people have, but they need to keep weekly snapshots, but also one every 30 days. That's like really hard to specify in one snapshot schedule. So you just put 2 snapshot schedules on there, and then the pruning would get kind of difficult if you have to specify that in the same as the snapshot schedule.
But it could presumably figure it out in the prune step. Yep. I would wonder if there are cases where a user wants to create a snapshot but doesn't want it to get pruned. There would be a way to like mark it as like keep forever, like that, or.
Yeah, so again, what borg backup does is you get these keep weekly, keep monthly, and you just give it a number. You can keep a number of snapshots regardless of timing. So you just say, I always want to have 30 snapshots no matter what. And you can also give it basically a prefix also on the name of the snapshot. And you can say like only prune these snapshots that are prefixed with whatever you want.
Okay. Right.
And that's yeah, and that's what I kind of mean with separating the two. You get much more flexibility in what the pruning does as opposed to what kind of snapshots you have.
Okay. The one thing that I like about the original proposal is that if you do like an ls whatever, you would get a single table that would show the directory and when you're taking the snapshots and also how long you keep them. Like you could see the complete view of the snapshot schedule and the pruning schedule. I wonder if we separate out schedule and the pruning into 2 different pieces, if it still makes sense to have a combined view that shows.
Yeah, I think it does.
And they would just end up empty boxes. They don't line up.
Yeah.
Something like that.
Yeah, I think it does. I mean, and again, the question is, what do you do with manual snapshots? Do you list them in this kind of view? But it still can be figured out. I mean, you can also another benefit I think of the separate pruning is that you can actually run it manually. Like you don't have to rely on the schedule. You can go like, okay, prune to according to the schedule right now, and then we could even actually add a dry run, and it'll tell you like, okay, I'm going to prune this, and that would make the user experience I think a little better because less surprises.
That's the apply command that you have here.
Yes.
Cool. Yeah, I like that idea. Okay. So do you want to maybe flesh out the complete? So you want to work on this, right? Is that what I'm interested in?
I was planning to work on this anyway, yes.
Perfect. Okay. So maybe consolidate this into like a combined view of this is what the CLI interface should look like and what it should output, and then we can.
Sure. Sounds good. Slight hitch, maybe I'll be on vacation in like a week and a half, so don't know if there's any.
I think we'll manage.
Hard timing in there. Yeah.
I don't think anybody was expecting to start this tomorrow.
Okay.
Yeah, I wasn't. Certainly. Okay. Okay. Well, that all sounds great, and that's just the snapshot management and pruning. I guess Well, I guess the meta question for Jason is, should we try to mirror the same thing for RBD? And does it make sense to do that either from the CLI? Because here the CLI is going to be sort of combined with the Ceph CLI. RBD has its own CLI.
I think it's still important to have some consistency.
Consistency, yeah.
I mean, I also imagine someone's gonna add it to the dashboard because we already can go do the configuration. So define schedules in the dashboard and yada yada yada.
Yeah. Would the
So
RBD
another thing we need to consider is how we should integrate this with the volumes interface. Should we be using volume names rather than file system names, and then maybe subvolumes instead of paths? The downside of using or just tying ourselves to volumes and subvolumes is if they're not using it, then I don't know, we'll need to provide another interface to snapshot a particular path in the file system.
Especially if you want Kubernetes or something like that, where you're doing everything on subvolumes.
Yep.
Yeah. So I mean I guess the FS name here is really the volume name. FS name and volume name are the same thing. My assumption was that you could specify this on a subvolume or on an arbitrary path. I don't know if there's like a combined syntax that would maybe let you specify a volume or a volume and subvolume in the FS property.
I mean,
but
if
at
there's
least
some reason we don't want to just take the really easy translation from the subvolume to the absolute path, Patrick. Like the volume client would have to do it, but it already does all that anyway, doesn't it? So,
are you suggesting that the subvolume module would just call out to this other command line interface to set up the snap schedules, and then give the actual path instead of the subvolume name? Yeah, that's one option. That might simplify the coupling too, because when you delete the subvolume, you're going to want to, the subvolume module is going to need to go out and delete all the snap schedules.
I mean, the actual path for a subvolume is something weird, right? So I think you definitely want, at a high level, we want the convenience of being able to specify a subvolume ID, the snapshot of entire subvolume. But I think we'd also want the flexibility. It seems like it doesn't cost us anything to have the flexibility to also specify a specific path within a subvolume, or the volume or whatever, because the snapshots can do that, and there's no particular reason why we'd want to
we can just do it with. We can just do it with option names instead of additional arguments then.
Yeah, I was going to suggest that too.
Which isn't necessarily worse, actually. That might be easier for people to work with, and if we change the syntax, it won't break all the pre-existing scripts.
Yeah.
Sorry, I missed what we're just proposing. What is the proposal?
To have optional arguments to specify subvolume. I think that was the suggestion.
Okay.
And so the path would be an absolute path in the volume, or if you optionally specify subvolume, to be a relative path in the subvolume. I think that the volume name is required, right?
Yeah.
But it could be, well,
another option is to just provide a separate interface in the volumes, which just wraps the snap schedule. It's a little cumbersome, but that could be easier.
We'd probably want to mirror it one-to-one so that it behaves consistently. But that might work too, yeah. Yeah. Okay, well, something to decide.
I did have one other question around this, which is I don't actually know what a reasonable limit on the snapshot creation rate is anymore, but there probably still is one. I mean, I know we went through a lot of work to make keeping around pruned snapshots less expensive in the OSD map processing, but like, creating and especially pruning them does still have a cost. I hope we want to surface that here by not letting people specify automatic creation not less than an hour or something else, but we should probably think about that.
Yeah,
I mean, that could be configurable, right?
Yeah.
Like have a Ceph option say like minimum snap interval or something.
Well,
like that.
yeah, but we can also design the interface to encourage reasonable behavior rather than having them go, wait, why won't it let me like it?
But
like
doesn't that
if we don't
depend on the
support
cluster?
seconds.
What's reasonable?
Yeah, I think so. But we can set a
yes,
default that's
but
reasonable.
I mean, so there's sort of two ways in which it matters. It scales on like there's a per OSD cost and there's the processing the OSD map absolute cost. And we've tried to make the processing the OSD map cost get lower, and Sage is doing some other work to continue making it lower. But so that means actually it's going to be less of a per cluster cost, except whether you're on like SSDs or hardware.
I mean, my gut says that the minimum should be like 5 minutes, or maybe in the extreme 1 minute. But
well, I mean,
like
that's
like 5
see,
minutes.
I could be wrong. I would be very unhappy if someone gave me a support case for a cluster that had done that. Like that's a lot of work.
Well, we can, whatever it is, whatever the reasonable is, we can set the default value for the minimum snap interval.
Well, that's what I'm saying though.
I don't want to
yes,
ramble on a discussion of what the specific minimum is right now.
Yeah, but I mean, but like we can, for instance, design the interface so that it it allows specifying in hours but not in minutes or something, and we might want to think about encouraging more reasonable values. I
would lean towards using the generic time parsing interface that lets you specify, 1W for a week or 1H for an hour. Because then you don't have to recast everything in terms of weeks or something like that. It's a natural way to describe it.
I guess just because if we let them set a minute or 5 minutes, then basically every write is nothing on disk is going to be adjacent to anything else, because every write will have to be a new version.
Yep, right. So we should have a minimum snap interval.
Anyway.
Okay.
There's one more thing I want to bring up. If we have hundreds of paths all with similar schedules, and then we also have the corresponding task of mirroring those subvolumes on those schedules, then we deal with these, presumably the manager is going to spawn off a bunch of containers, and I'm getting a little ahead of us, but I think this is relevant to the snapshot scheduling. Then we're potentially mirroring hundreds of paths all at the same time on the same schedule, and that could be somewhat disruptive to the cluster.
Like if everything happened
if they weren't
24 hours, 1,000 things mirror it all at once. Is that what you mean?
Yeah. If we could introduce, I don't know, not actually have it, all of them synchronized on a 24-hour schedule, that would be optimal. But how do we express that?
Well, what's the goal for this mirroring then? If it's just to have kind of up to date, is it just to have kind of up to date backups when you do the synchronization, or? Because I mean, we could just compress them all into the same snapshot at midnight, and then over the course of the day migrate them. Is that
one
plausible?
Option would be to have in the schedule you specify the interval, and by default the offset within that interval is randomized or whatever, but maybe consistent for that particular schedule. Or alternatively, you can specify a strict specific offset of 0. So it's exactly at midnight or whatever it is.
Well, but I mean, that's forcing them to be distinct points, whereas it seems like we'd want the snapshotting to be unified as much as possible, and then just the migration to be offset. And so that's why I'm asking: does the migration need to be like almost live, or like what are our target use cases here?
All right. Well, maybe we should skip ahead to let's get to the mirroring part. I think there are a couple of different pieces there. So I briefly mentioned 1.5. There's a pull request in flight that adds a new primitive to SFFS to flush all the RStats for a snapshot, which will be necessary so that any subsequent rsync that you do on the snapshot can use RStats to optimize itself to skip unmodified directories or whatever. So we should make sure that gets in. I had a question about whether that's something that we want to surface in general, because right now when you create a snapshot, it's sort of a fire and forget asynchronous thing. The snapshot is logically created when it returns, but currently if you go and read from it, it'll block while the metadata locks or whatever happen, and the RStats are going to converge on a stable value at some point, seconds or minutes later. Does it make sense to have any kind of feedback on something like that? Is that something that you've thought about, Patrick? Or is it the sort of loose approach that we have right now sufficient, do you think?
Well, I've some wondered why we don't force all the clients to give up their caps so that we can solidify the snapshot on creation. But there's a lot of value in having this done asynchronously and quickly. So I don't know. I haven't really thought about it too hard.
Okay. I don't know if Jung is on the call. Yeah, he is. Probably something we can. Yes.
I'm sorry, it's been a while since we've gone through this. So when we create a cap, the MDS notifies all the clients and waits for an ACK, but it doesn't force the cap return in order to get everything up to date, right? So
right. Well, in general, there's no. Right. There are two things. One is that when you create the snapshot, the actual flushing of the snapshot is totally asynchronous. So the barrier happens on the client side, and it will, in the background, write out all of its dirty data for that snapshot. So snapshot doesn't really complete until that happens. And then separately, when the snapshot's created, the MDS basically broadcasts to all clients that they should create the snapshot. But there isn't a two-phase thing where all clients quiesce in coordination and then create the snapshot and then proceed. And so the snapshot point in time is coherent within a particular client, but not across all clients. The performance trade-off that we made, because it was cheap to do it on a client, but not cheap to do it across clients.
Well, we do get the ACK though, so we know that all the clients have seen it, or is it just a broadcast, fire and forget? I thought
when the snaps are flushed, that's an ACK on a granular basis as all the caps get written back.
No, I mean, so the client sends a snap create request to the MDS. The MDS sends out a make snap to all the clients.
I can't remember. There's an ACK.
Anyway, so I mean, the feedback we need is basically, okay, all the clients have written or the feedback we could need is, okay, all the clients have actually written to disk, and then our stats have gone all the way up the tree, right?
Yeah.
And I think the MDS knows when that happens. It's just not really, there's not a clear flag point that the users can point at.
Well, the RStat propagation, it doesn't really know right now, except for this pull request that's in flight. It's going to fix that up. But again, there are multiple states. There's all clients may or may not have logically taken the snapshot. All clients have taken the snapshot but haven't written back their caps. All clients have flushed their caps, and so all the data in this snapshot is stable, but the RStats aren't yet consistent. And then finally, all the RStats have converged. So it's 4 phases of whatever. And right now, there's no real transparency into which phase we're in. So that might be something that independently we want to provide visibility for. But I think it's not necessarily blocking any of this, but it might fit into like a larger view of how we want to sort of consolidate the user view into snapshots. Maybe, I don't know. I'm throwing it out there. Okay, so
so if you try and read a snapshot immediately after it's taken, does the CAP system actually force the write back to happen first?
Yes. Yep. Yeah, there are a whole set of lock states that drive that.
Well, just because we do shortcut some of it for snapshots because they're read-only.
Right. Once you get data to the client, it never changes. No. With the exception of the rstats, which is why that's sort of a loose end. But aside from the rstats, no. It is read-only. Yeah. But the client will block until the block state changes after it flushes on the clone inode or whatever it is. Okay, so the goal of the snapshot mirroring is a sort of the simplest DR model. So you would specify the source directory on one cluster and a target directory on a remote cluster, and some sort of schedule, how often you want to synchronize it. And the basic loop would be you would create a snapshot on the source cluster, you'd synchronize data from that snapshot, or you'd flush it, make sure the rstats, whatever, you flush the snapshot, copy it all to the remote cluster. After that snapshot is copied, you take the same snapshot with the same name on the remote cluster, the same directory, and then you'd loop. And getting back to your earlier comment, Greg, the idea here would be that it would be a self-regulating loop, so that if you specified a 10-minute schedule, for example, but then it takes an hour to copy all the data, then it would only happen every hour, right? You don't want to have the creation of these ephemeral snapshots that you're mirroring be disjoint from the actual synchronization, and because you don't want to create more snapshots than you can synchronize, it's kind of pointless. And originally I was thinking that maybe this should be directly linked to the snapshot schedule, but I think the comments on this pad seem to suggest that probably doesn't make sense. This should be a somewhat separate feature, because the snapshot schedule is about snapshots that you're retaining for the user's benefit, and the snapshot mirroring is probably something where it'll mirror any snapshots that already exist, just so that it mirrors the whole thing from point A to point B, but then it'll also create its own snapshots at some configured granularity to have to make sure it has an up-to-date copy on the other side. So I think we need to, yeah, go ahead.
I was just saying, is this the same issue then that RBD mirroring has? You have to have two clusters that can fully talk to each other. And like basically mount two file systems on like one server.
I think less so, because all the inter-cluster communication could be like via rsync, for example. That would be sort of my first thing that we'd probably implement. It would just be like a naive thing that just is literally just running rsync. And so in that case, rsync can tunnel over SSH or whatever, and so you could do it that way. Necessarily have to be connected that way. You could have managers talking via some protocol to other managers, and then spinning up rsyncs that are talking to each other via some temporary host. I wonder also if we should try to write this in a way so that we could enable you to have the target be not Cephfs. So you could be mirroring to some other random storage, as long as it has the ability to create a snapshot and delete a snapshot with a name that has the same format or whatever, then like it shouldn't really matter, right?
I think that would be quite valuable.
Yeah.
Just for flexibility's sake.
Yeah.
So there's one big thing that the RBD, not the journaling mirroring does, but that the snapshot disaster recovery does, which is that you can do diffs. Have you thought at all about how to do that in the file system? Because like
that's point 4.
Okay,
yeah.
I missed that one. Well, not entirely, or maybe it. well, maybe entirely.
You're just talking about because only portions of the file might have changed, so that
Yeah, so like we don't track that explicitly in the file system at all, but we could still like go query the Rados objects for their differences. And the reason we might want to think about that earlier rather than later is because you know, you can create source files. Maybe no one does. Maybe it's not a problem at all, but I'd be worried that if we assume that we've like found how frequently you can snapshot, then suddenly someone creates like a very large source file, then suddenly we're based off of the like logical size, logical created space rather than the actual like cluster throughput.
Yep. I mean, yes, sparse files.
And I mean, like, we could still do that if we were, even if we were driving rsync, because we can like, or if we're like wrapping something that drives rsync. Because we just like go say, oh, okay, we know what the ranges are, and just like copy those ranges instead or something. And actually, I mean, I guess technically rsync does its.
I think that's pretty much that's
maybe
what,
it's not a problem.
That was like the Gluster approach to mirroring, right? They basically wrote dirty extents to a given file, and then they said rsync, go look at these extents. So if you had some magic file that showed the the dirty extent range between this snapshot and the previous snapshot or something like that, that you could basically feed it right into rsync.
Mm-hmm. All right, maybe that's not a big deal then, because rsync is efficient in its transmission. I've forgotten that.
Yeah.
I mean, I think it is, right?
I like the idea of it's doing all kinds of cleverness, right? It's even like making a Merkle tree, something like a Merkle tree. It's hashing both sides so that it knows whether or not even consider copying whatever. It's doing all kinds of crazy stuff. So I like the idea of building an rsync just because it's you can do the simple thing and it'll work. Then you can refine the optimize from there. And also because it will generalize to non-CephFS targets, whereas if you write a special tool that is comparing two CephFSs with some weird metadata introspection, then it's tied to CephFS on both ends. And I have a feeling we can do pretty well with just by modifying rsync in certain ways to optimize. For example, by looking at the RC time to avoid looking at whole subtrees that haven't been touched.
My main concern with using rsync is that it's just so slow on CephFS, and once we start using rsync, it's going to be hard to convince ourselves to stop because it does have a lot of fancy bells and whistles, but
I mean, it's slow on CephFS because it has no optimizations for us and does things that we're slow at, right? But we could fix that.
No, I'm talking about it, doing serial opens and closes. It's not designed for a distributed file system or high latency. And getting it to do things in parallel is a huge engineering effort that we can't undertake for rsync.
So if we start with rsync as the simplest, naivest thing to do, that would remain an option for non-Ceph targets. And then if we then, as a phase 2 or 5 or whatever it is, have a specialized CephFS sync that does all the cleverness that we want, we could support both.
Well, I mean, would we really do anything more clever than just spinning up multiple instances of rsync on subtrees?
Yeah, because we can create parallel. We could do parallelize that creates in a directory example. All the metadata operations, whereas rsync is the serial example. If we could identify a big directory hierarchy got renamed, and we know that, we could just rename it instead of recopying all the data.
Could you have like batching of operations on the metadata side too that rsync couldn't do through POSIX?
Yeah. If it's comparing snapshots, it could a customized sync could look at the Rados. It actually ask Rados if there's a delta between the clone and the actual object or whatever from the snapshot, and skip that portion of the file as opposed to just copying it and noticing it's the same. like reading the data. But, I mean, there's a bunch of stuff that we could do to make it all better. But that's sort of like even if we did all that, we would probably still want the rsync option for the non-Ceph targets backup file use cases. So seems like a good place to start. And I have a feeling that it'll work well enough for lots of use cases.
Well, I mean, and you can, even within a directory, you can just invoke rsync on specific files.
Yep.
The reason I mention this is because I've never worked with the rsync source community, but we are a Linux file system, so
yep.
Then they do a lot of per FS customizations, I think. So presumably we can get stuff in if it goes through the Linux kernel interfaces.
Right. So for example, having rsync look at the RC time in per unit search would be probably the first optimization that we'd want to do.
Yeah. And if we built our own Ceph sync, maybe we would build it all the way, but it wouldn't surprise me if we were just wrapping, telling rsync which files in a directory to look at.
Yeah. And
then we could,
or something like that.
Yeah, and then we could fire up an rsync for every 10 files we care about or whatever.
Okay. So I didn't define what the CLI would look like for the mirroring part. I think it makes sense to pin down what the snapshot scheduling one looks like first, and then build this one. But it would, at a high level, would be similar. The idea would be to specify a volume, subvolume, a path, and then where you want it to go. You'd have to have some other description of how you connect to that remote cluster, which remote cluster it is. So you know how to talk to it. Maybe that would be orthogonal so that you have multiple directories mirrored to the same cluster. You don't have to configure all the credentials multiple times. Whatever, there's a whole, you could iterate on that a bunch. But the assumption would be that there'd be a manager module that is sort of managing the process. It would spin up workers via the orchestration API to do whatever it is to do, scale out in a similar way to the way that RBD Mirror does it. Probably use similar strategies there. So part 3 is once you have a DR copy on the other end, you copy the snapshot and then all the contents of a snapshot, and then you take that snapshot. So once the snapshot exists, it's identical to the one on the source. But then immediately after that, you're going to start, or shortly after that, you're going to start scribbling over it with the partial contents of the next spot. And so in order to actually make use of the backup, you probably want to roll back to the most recent snapshot on the destination, which is the most recent consistent view of that portion of the file system. And right now that isn't easy to do in CephFS. RBD has a snapshot revert command that does it not atomically, but it does it for the whole image. CephFS, you just have to rsync out of the .snap directory basically in order to do a rollback, which is less than ideal. So I think one question is, should we pursue an efficient or streamlined rollback process for CephFS back a directory to a snapshot? Might that work? Patrick, Zhang, have you guys thought about this?
Not yet.
Yeah, I haven't thought about it yet either.
Yeah. Right, well, maybe I'll just flag it as something we should think about.
Yeah, I mean, we talked about it in the distant past, and I think there were, the options either are to try and just, do it from the MDS, but then your cluster's stuck, or else you need to, tell the client to prefix every op with, every Rados op with a rollback, which I think is what RBD does, right?
It walks every object and calls an operation that says roll back to this snapshot, and it will copy it into place as.
But that's a lot more plausible on when you're limited to the size of an RBD volume on a whole file system.
Yeah, I think once we identify a changed file, then it'll be roughly the same thing for that file.
Yeah.
There's a metadata part of that has to roll back.
Yeah. Well, so that's the question. It's like, do we just like we can either. So yeah, that's the thing we could do is just like have the MDS whenever a client opens a file that hasn't been rolled back, they could like block while the MDS goes and performs it.
We could do that. That would require the client to have special rollback behavior.
No, I'm saying the
the
MDS. The client issues the open, and the MDS goes out and does the rollback like before the client. But well, I guess it wouldn't be on an open. It would be whenever the client asks for tabs on
I guess
something.
my assumption would be that it would be like with RBD, it would just be a thing that you run that takes a long time that does the rollback, and it's sort of a slow incremental process. And then only when it's done do you have a fully rolled back thing. And while it's in progress, you don't have a.
So in that case, clients would see a partially rolled back. What if they do it right in that time? So the client would see a partially rolled back subtree during that time?
Yeah, I mean, you'd just be like writing all over the head version of the file system.
No, but I mean a concurrent reader of that subtree after they've executed the command.
Yeah, while you're rolling back, if you're watching the contents of the file system, you'd watch it slowly change until the rollback is done. And then once the rollback is done, then you're like, okay, now it matches what the snapshot
Well,
was.
and so like the cluster admin needs to somehow block any client from doing anything until to any object to any file that hasn't been rolled back.
This is a backup, right?
I understand that.
They're not using it until they're say, okay, I'm ready to use it.
And the behavior is well defined, right? If you do a write to something that hasn't been rolled back yet, you lose your write.
Yeah, but how does the admin know whether it's done or not?
I mean, they would.
It's no different than if they were receiving another backup event from a remote cluster, right? They'd see it gradually change and then finish changing.
Well, my main concern is that, like, say go ahead.
I mean, you could do it in two ways, right? You could have a blocking command that does the rollback, and when that command finishes, then you know you're done. Or you could have an asynchronous command that starts the process, and then you have another interface that lets you query whether it's complete or not. Either way, it'll take some period of time to roll back, and only after it's done do you have a rolled back version.
I mean, unless there's some reason people would want an atomic, lazy operation that magically gives the appearance of. It's hard
well, there's a really good reason.
Does that exist in other backup systems?
Yeah, that's what I'm saying.
A regular rollback and restoring from backup, usually you're just writing over the whole tree like this. What we're talking about here, right?
I mean, with RBD, you can kind of simulate it by creating a copy on write clone of the snapshot that you're back to. But that's a slightly different thing.
So I guess my main question is, or my main thing is that, okay, so a disaster happens and you're failing over to this site. Then the admin, wants to turn as much stuff on as quickly as possible. And so communicating how they do that is going to be hard. So I'm wondering if there's any point, like this would be a little faster, I guess maybe, than just having them do a copy, but I'm not convinced it would be a lot faster unless it was like asynchronous and lazy.
Why wouldn't it be faster? The OSDs can do it locally. It's pretty fast. I mean, the MDS.
I mean, yeah, but is it like enough faster than for the interface trade-off?
I mean, it's probably the same set of optimizations that you would do for doing the rsync of the copy itself from cluster A to cluster B to only capture the changed portion when you're doing it from the local snapshot to the head. Like it's just like almost it's the same thing. You're copying from the snapshot to the head, and you want to do it. So maybe that's the answer. Maybe it's just running rsync with the same set of magic settings locally.
Well, the only difference is you would be able to do a lot of stuff local to OSDs without having to actually send the data. If you did it with rsync, it would presumably actually send it to the client back.
Yeah.
That seems like a sound reason not to, actually.
Yeah. Well, it's like with most of these, it's an orthogonal direction. So if we want to optimize that particular aspect of it, we can either do the naive thing or we can do the extremely clever thing.
I guess I just think that if we're going to do snap revert, then we need to like block that like access to the file system until it's done on whatever scope you're invoking it. because otherwise there's too many weird ways it could break that people will do.
It seems like a pretty good argument for just adding an arbitrary subtree lock. It does make it totally orthogonal, right?
Yeah, as long as the rollback itself is allowed to proceed, but everything else is blocked. It might be something. That might be nice. Okay. And then the last thing is just how do we make that rsync fast? So the naive thing is just to do rsync with no optimization. The first optimization would be to use the RC time, which will require that rstat flush pull request to commit so that we can actually rely on it on the source. But I think that's something that would make sense to add to upstream rsync anyway, with appropriate documentation to make sure that they run the right sync command on the source before they use it. And then the alternative would be to, write our own sync tool that does something super clever, which might, I think, defer to another another day. Start with the simple thing. We could identify. We'd have a pass that identifies, builds a file list, and passes that to rsync. That's one option to sort of plumb the two together. There's a bunch of stuff we could do. We could have specialized MDS commands where you give it the first and second snapshot or the snapshot in the head or whatever, and it'll give you a consolidated list of just the directory items in that directory that changed, whether they came or went, and so on. Or you could just sort of infer it from the differences, and that's it. So there's a lot. I think there's a lot of possible work paths here. I think starting with the snapshot scheduling seems like a good place to start, but probably the next step or the parallel step would be to figure out what the interface should look like for describing the mirroring, how you would configure it.
Yep,
in a generalized way that works both with Ceph targets and non-Ceph targets.
Yeah, I think it makes sense to flesh out the snap and pruning CLI experience first and then see where that goes.
Lessons learned probably from that. I think we also need to pick a name for it. I like the simplicity of RBD mirror and the idea of mirroring that. So having like CephFS mirror maybe is a simple thing, or CephFS snapshot mirroring. We just can't use snap mirror. And I think snap mirroring is probably, if we go ask a lawyer, they're going to say no, because lawyers always say no. But even if we didn't ask a lawyer, we're probably gating.
How about CephFS mirroring instead of to mirror the RBD mirroring?
Yeah, that makes sense.
Yeah, I think that's fine, especially since the snapshots are, loosely related to the mirroring. You can use the snapshots without the mirroring.
I don't love that because the RBD mirroring is actually like journal tailing, and they have like the snapshot and the snapshot diff stuff that is also in use for this.
So I guess that's a question. I kind of asked this earlier for Jason. The RBD mirror daemon, I asked if the mirror daemon is going to be the thing that drives the RBD snapshot mirroring thing. Would you imagine that it would all fall under the RBD mirror feature set, and it would be different modes? It would be like continuous write logging versus just contiguous snapshot based. Like that.
Yeah. So yeah, that would be the goal. It's still set up RBD mirroring because you still have to have that background process that is like still trying to do the rsync in the background to get the data over, right? So, and that's what RBD mirroring is doing, because you don't necessarily want to rely on the inter-cluster live migration to. You have to touch the data block for that data block to migrate. We want to have some process kicking all the data blocks over, no matter what, and that's the RBD mirror daemon.
And all the connectivity and infrastructure would be the same regardless of which mode you're using, I guess.
Yeah. That
So, okay.
one setup. Yeah.
So I like that, and that makes FFS mirror make sense. I think the only thing that I think we should keep in mind as we flush the rest of this out is that we should be thinking ahead to what future mirroring modes we might have for SFFS. Why, like a contiguous one where we're continually like sending changes as they happen in real time across the remote site, and possibly bidirectional replication in two directions. So we should just, if it's all going to fall under the same set of mirror capabilities, we should try to make sure we aren't boxing ourselves into a corner in terms of the way that we frame an API or describe something or whatever. Yeah. Okay. Patrick, do you have any other thoughts or comments on this? What do you think?
Yeah, that sounds good. Don't have anything to add.
All right. Okay. All right, thanks. I think that's it on that one. The next topic is Rados progress module. Josh and Junior? No.
Yeah, so background on the progress module as it currently exists. Essentially, it measures the progress of recovery when an OSD is marked out, but for no other circumstances today. So it just takes a look at which PGs are affected by an OSD being marked out, and then tracks via the PG stat updates that come in roughly how much data has been recovered, not counting OMAP, just counting the regular data that exists right now, and displaying a progress bar in the Ceph CLI. And there's some there's a PR that listed at the bottom of the pad there to integrate with the dashboard too. So I guess at a high level, there's a couple of different paths we can take in terms of trying to track recovery progress. One is trying to track just the global and estimating like how much time there's left to recover across the cluster, regardless of cause. The other is trying to track more individual causes and effects. So like when an OSD is marked out or in, seeing tracking how fast that's going and whether that's done or not, or similar changes like OSDs being reweighted or some kind of crush tunable change, or things like PG splitting merge or the balancer. So I think Junior's already started working on some of this with looking at the in events now. And that part seems relatively straightforward in terms of it being very similar to the existing out events. I was kind of wondering if it might make sense to try to track some of the other causes at their source, like in the PG autoscaler or balancer modules, have them maybe create their own progress events.
I like that idea if we can figure out how to have like a clean interface so that they can fire off an event and populate it with some initial metadata, but then the progress event handles the like ongoing maintenance.
Right.
I think actually it was set up to do that, but I haven't actually seen an implementation that does it yet. I don't know if the
yeah, there's one existing module that uses the progress module, I think, or the orchestrator module, that's the one. But it doesn't, it's not really a well-defined interface in terms of tracking that. I guess in this case, we just want to track the recovery work kind of in a similar fashion we're doing for the other kinds of recovery. Yeah. So it might make sense to try to keep that within the progress module itself.
I like the idea of having something else that does some sort of discrete event that causes activity in the cluster, generating own events that understands what completion means.
Mm-hmm.
The balancer seems like a good candidate, except that kind of the way that the balancer works is a little bit, it's an incremental, like hill climbing type of thing, so that it's always going to take small steps that are going to trigger some activity. And then once it gets close enough to the where it stepped towards, but not necessarily all the way there, it's going to take another step. And so I'm not sure it maps cleanly onto the idea of having a start and an end state and actually knowing where you are in that process. It could estimate, I guess, but it doesn't it doesn't always know what the finished state is, even, right? It just knows that it's moving closer to a better solution.
Right.
So it's hard to make a bar that's about 70% done. I just know that I got a little bit better last iteration. But maybe there's another piece that we can.
Yeah, I guess like from a user's point of view, it does kind of make sense to know whether the balancer thinks it is still has more work to do or not. At least maybe not down to the granularity of a percentage complete, but
yeah. Or even if each step had its own event. So, I mean, one of the nice things of having the progress events is that if you're looking at a Ceph status and you see a bunch of rebalancing going on, just like knowing why it happened, what the root cause was. So even if the balancer made a short-term event that says, I took a step to try to improve the balance, and I'm 70% done with that. Even though it's going to disappear and it's probably going to take another step after that, that might still be valuable. It might be a more doable thing.
I think one thing we want to be careful about is not having too many progress events at once. So if the balancer ends up like taking a bunch of steps, maybe trying to batch them into one progress event, or
close out the previous one, or modify the previous one.
Right.
Yeah. Yep. So I think I have, I guess, two questions. I think one of them is here, which is like, should we try to have a very general type of event that captures every source of recovery? And this one, I have a hard time wrapping my brain around, figuring out how it would work and what it would actually do.
And maybe it doesn't make as much sense as a progress event, but just as a general part of Ceph status.
Yeah.
Like when you see
estimated time to clean.
Clusters, estimated time to clean or something like that, or time to active at least.
Yeah. Because the second thing that is missing right now that might be pretty easy to add would be to annotate every progress event with a start time, and then look at the current progress percentage and just extrapolate when the estimated end time is.
Yes.
It won't be super accurate because most of the events tend to make fast progress early and then slower progress later, but it'll at least be something. And the further along you get, you'll have some projection. And even just knowing when the progress event started is probably valuable. Saying this is a 2-hour-old progress event versus a 2-minute-old one or whatever. But that might be an initial add.
There.
Yeah. Yep. And estimated time to completion, that could be a generic thing. But it would be what you're suggesting is slightly different because it wouldn't actually be tied to a progress event. Or in addition, separately, we could also just look at overall PG states.
Right.
As part of the PG status and estimate time to active or estimated time to.
So that could just be part of the regular manager processing of the PG map, essentially.
Yeah. Yeah, that might be pretty useful. It raises a whole separate set of questions about how you do that. Like, would you look at the 1 minute, 5 minute delta in PG states and extrapolate from that? What's the right time period to extrapolate from?
Yeah. I think you probably don't want to do this. You don't want a simple linear extrapolation because you do have that long tail effects where some PGs take a little bit longer to recover than others. Maybe you extrapolate based on some kind of curve with the tail like that.
Yeah. Yep.
but the exact method, it probably makes sense to just get as a starting point estimate based on what's in the PG stats, and the delta over a certain different period of time, maybe moving average of like the recovery speed for that PG.
Yeah. Track bytes and recovery. That's also a good idea, and also unrelated to this directly, I think.
Yeah. So today we have the number of bytes recovered in the PG stats, but we don't track the OMAP recovery quite in the same way. Like, that might be a little bit harder. We have the lazy OMAP stats that now are collected during scrub, but we don't have exact like byte counts. I don't think right now for.
I think they'd be pretty easy
OMAP
to add,
recovery.
Like it's probably just a matter of adding the column to the PG.
Yeah, I guess it would let us estimate the speed at least, even if we don't have an accurate total size.
Yeah. Yeah, we have a num bytes recovered and a num keys recovered. We just add a num key bytes recovered or
Yeah,
num OMAP bytes recovered. It'd be pretty easy. Having like scrub rates also might be interesting, knowing that it's scrubbing at 100 megabytes per second or whatever it is. Interesting. Well, just looking at this, it seems like easy next steps would be, this first one already has a PR that's under testing. The second one would be adding the estimated time of completion for a progress event. That could be done, a generic change. And the OSDN thing, junior, that you're currently working on. The big question for me is if there's a way to try to generalize a way to capture some arbitrary change in the cluster that generated a bunch of PG migration, whatever, in a progress event in a sort of a catch-all way. Does anybody have any like intuition, insight, ideas about how that might work?
You talking about beyond just looking at the PG stats and states?
I mean, beyond. Currently, we're specifically looking for OSD out, OSD in, or some other event, and crafting events based on that to have a sort of a catch-all that will capture PGs that are doing something for some unknown root cause.
You mean something beyond regular moving objects around sort of behaviors? Or are you trying to?
Yeah, I mean, like say somebody changed their crush tunables,
right,
or something, and a bunch of PGs started moving. Like, does it make sense to just have a generic progress event that comes up that says PG rebalancing, 70% done?
So if it's
even though we don't understand why it happened.
If it's a sort of objects moving around deal, I mean, that seems like the progress event would be, we transitioned from this many objects are in the right place to this many objects are in the right place. Or wrong place, whatever, either way.
Or PGs in this case.
Well, objects would be general, right? Or this many megabytes of this many objects are now missing from where they're supposed to be.
Right, that's the easy case. The harder case is somebody was down and comes back and he only has to fix up some stuff based on the logs.
Well, that's the same deal, right? They emit an event that simply encapsulates, there just mentions, I have 10 objects that are not where they're supposed to be. That's the advantage of doing it over PGs.
I mean, that's right now all the progress modules basically looking at PGs. That's sort of the granularity it's considering.
Yeah, I don't think we have during recovery, the stats on how many objects are being recovered and how much space they take.
We have a count.
PG analog is, I have this many PGs that are not where or PG pieces that aren't where they're supposed to be. Seems like that covers everything, right?
I guess the question in my mind is, would we want to have this as like a separate progress event for global recovery, or just a part of like the Ceph status for the PG map?
Just an estimated time to completion.
Yeah, just estimated time to completion there.
Yeah, I mean, the estimated time to completion doesn't capture the like when did it start and how long it's been going and how much of it has been done, right? It just tells you when
Right.
it'll be clean. So having that additional information is kind of nice.
I think adding the additional information about, when there's balancing happening, we could probably create events using things like change in crush map or like the up map change to at least highlight if the balancing is because of things going up and down or things changing in the way crush is configured or the up maps are changing. That high level information is going to be useful.
Yeah. I think continuing to do that, like pick off the most common things and creating events that identify a specific root cause, I think definitely makes sense. I think the question is whether we want to have the long tail generic event that captures. I don't understand what happened. I just know the PGs are moving.
Seems like that would help in the interim between before we, or maybe we never end up implementing every single possible root cause for data movement.
Yeah, we'll never do that.
So probably makes sense to have the global one in that case.
Well, isn't the statement about what needs to be moved orthogonal to Y?
Yes, except that it tries to group them into an event, right? So if you have an OSD's marked down at time A, it'll create an event that identifies specific PGs that are effective, and that'll make progress. And then 2 hours later, another OSD is marked down. It'll create a distinct event that identifies different PGs that has different progress. And so you can see that, oh, the first thing finished healing because of that other event, but it's still whatever. Whereas if you're looking at an arbitrary set of changes, like how do you know that suddenly a bunch of PGs are moving? This is the set of PGs that I'm going to group into this event with an unknown root cause. And then suddenly 30 seconds later, another PG is moving. Do you like add it to the previous event, or does it a new distinct event? Or
each PG void sort of event has an optional associated cause kind of deal. You can associate them based on cause.
Yeah. You just have to figure out which one you have to group. It's like a grouping problem.
Yeah. And
you're examining the state of the system at discrete time points, every minute or whatever it is that the module wakes up and looks at things. You have to figure out. And it's not even, I think what it's doing is, if I remember, it's waking up on every, on new OSD maps, it looks for changes.
Mm-hmm.
But even that isn't quite right, isn't quite sufficient to just map it to that epoch, because you have follow-on changes where the PGs are appearing and they change their PG temp mappings or whatever in response to that same key event, and that happens in the next couple of epochs. So we probably have to define like a window or something where maybe it's just that any PG mapping change that's within n epochs of an existing event just get grouped into that same event. We don't understand anything else about why it happened.
Yeah, maybe it's helpful to think about like what kinds of use cases people would have for looking at these kinds of events. Like for the OCI case, I could see it being helpful when someone's trying to migrate data off an OSD before taking it out of the cluster. They want to know when that OSD is safe to remove. We already have those kind of commands, but being able to see, I've got some other recovery going on somewhere else, but I also know that this OSD is almost done getting data migrated off of it would be helpful.
Yeah, these feel like it feels like the goal of this is to have some sort of qualitative cause and effect understanding for the operator, just so they know why the cluster is doing work. But anytime there's I need to wait for that thing to finish before I do X, there's actually some, like, the markout case, you want to look at like safe to remove.
Yeah, safe to remove.
There's specific criteria that relate to that. But just having that understanding of why the cluster is doing something is, I think, really important, both for peace of mind of the operator, confidence in the system, our own understanding of like, yeah, why the system is doing what it's doing.
Mm-hmm.
Every time I like open up a Ceph-S and data's moving, I'm like, why? What's happening? I have no idea.
So if the operator sets an OSD out and it's halfway through that and he sets another OSD out, there's an intersection of PGs that were affected by both operations. So are we reporting, how are those being reported to not mislead the operator?
Can't remember. I believe what the current module does is it will just yank the PG out if it changed again. Can't remember. I took a look at the PG update. It kind of feels like either both events track that PG and neither event will complete until that PG is done doing its thing. That is a somewhat defensible approach. Or if another event happens that also affects that same PG, then it just gets dropped from the first event and it no longer cares about that PG and it goes that much closer to being complete. I think either of those is probably okay. Maybe the latter one's a little bit better.
I think the latter one is better because it matches the behavior of the first one completed and then the second one started.
Yeah, the second one did something else. Yeah. So we should check if, I think in order for that to happen, then the progress events would have to be changed. Right now it just has a list of PGs. In order for it to do this thing, it would also have to have a, remember the mapping of the PG. So if the mapping changes again, then it will kick it out and consider it completed. Although even then we have to be careful that when backfill starts and that doesn't trigger completion.
Maybe what Sam was suggesting before about tracking a cause per PG, that makes sense then.
Right. Instead of having it attached to a per event, but like a reverse mapping of PG to which event caused it.
Yeah, it's more like an
Perhaps you
mentions misplaced PGs and optionally the cause, and you group them by that basis. I kind of wonder if it might not be easier to do this from the OSD. The OSDs could send messages directly to the manager indicating who's misplaced and why. That would allow you to easily.
The OSD doesn't know why though either. Like the OSD doesn't know why though.
The primary does. Oh, I see. They don't know the original OSD map modifying it.
Yeah, they don't know it's because the crush map was changed, or because they adjust tunables, or because the OSD was marked out, or whatever. Who knows what? Crush hierarchy was restructured.
can probably look at the PG state for that, right?
No, that's a good point, though. The primary doesn't know whether it's because you marked an OSD down or because the crush changed.
Yeah.
They know the first map that caused it, maybe, but even then, not necessarily.
So backing up slightly, a real easy way to solve the problem of just having each PG owned by one event would be that when you create a new event and you add a PG to it, you just look at all the previous events and you remove that PG from all the previous events.
Right.
And if the module has a list of all existing events, it's probably a really quick scan to just do this out.
The module then has to be a bit aware about PG merging and splitting as well.
Right. Yep. So if a PG splits, then children get added to events. And on a PG merge, the source PG disappears. I think that's already handled. It'll just disappear. It doesn't exist anymore.
Mm-hmm.
maybe verify that.
But can you split and merge in any state other than active clean?
You can start the process.
Yeah, I mean, they go through a whole sequence of states.
Yeah. But I mean, the user, that is, can initiate a split or merge at any state.
You're right, the split can happen in any state, but the merge is only initiated if it's active clean. So presumably it wouldn't be involved in any. But we probably just want to make sure that there's a safety check so that if the PG, there's already something that checks if the pool disappeared, then the PG gets dropped. So we should do the same thing for if the PG number is less than PG number, whatever. Okay.
Well, I think what Sam is saying is that a user can set a target PG num that will mean merging a bunch of stuff. Is that an event right now or not?
It is not. That would be a good event.
Because yeah, so each individual PG merge only happens when they're active and clean, but they can like the targeting happens.
So PG autoscaler split merges up here, so we especially merge. That'd be a good one. So actually, that would be a good candidate for something that we can add, an existing module that we can add explicit event creation that knows exactly what PGs are affected.
Mm-hmm.
Okay.
Now it seems like we have a good list of initial stuff to work on and a bunch of other improvements we can figure out how to prioritize later.
Yep, agree.
Any other thoughts on this topic? Let's move on to the next one, is downgrades.
Yes.
So discussed this a bit in the past. There's an email thread linked from the pad there from last fall. The general idea is that it would be nice to be able to support downgrading within a major release, so downgrading from one point release to another point release, without having to worry about any kind of format incompatibilities or format changes that may have existed. Probably the first step here to consider is how to test this, because before we can test these kinds of downgrades, we're not going to be able to make them reliable. So we have the existing point-to-point release suites that upgrade between point releases. I think we can probably use the same kind of suites to downgrade. We might need to add a little bit more support in technologies install task to force reverse of packages. I'm not sure about that. And we would need to add more workloads than currently exist there. So things like with more than one RTW, more than one MDS. I think the workloads in the existing PDB suites are fairly basic, like Rados RPD things for the most part. So we want to capture a broader set of workloads that would include any kind of protocol changes between other components too. The another aspect that came up in that thread discussed previously was the testing the serialized formats that we have in the Ceph object corpus. One thing we could start with is the existing kind of test, but again in reverse. So we have this readable.sh script right now that just goes through and tries to decode every current and previous version from a given release. And we have some kind of whitelisting in the object corpus to be able to manually flag types as incompatible at some point. We can use the same kind of thing within point releases to at least check that we can decode things and not crash, which is kind of the bare minimum. There are a few points made about how to improve the corpus. Right now, it's kind of manually populated from workloads. I think Sage, you mentioned that there was a compile option that we can set to essentially dump out random structures while the clusters are running different workloads. So you get more realistic objects that are serialized rather than just the test instances that we have.
Yeah, I seem to recall that Kifu was going to look at scripting that a while back to have some automated process to do it, but I don't know if he actually did. But we have to do that anyway, independent of the downgrade testing.
Yeah, a lot of this makes sense for the upgrade testing too, right?
Yeah.
More workloads and better coverage of the corpus helps a lot for upgrades between any kind of upgrade, not just point releases too. So assuming we have the testing in place, we also need to keep more things in mind when we're backporting changes. We need to be much more careful about on-disk and on-wire formats and make sure we're not changing things in a way that is going to be misinterpreted by a previous minor release. But that's kind of helped with pure object corpus testing. But there are some classes of things that aren't included there, things like protocol changes, where you're sending new messages or changing the meaning of existing messages or the ordering of which they're sent and how they're interpreted. Usually we've used things like feature bits in the past, but oftentimes that's been kind of once the feature bit is there, we assume it's always going to be there, rather than having considering the possibility that it may go away. So we may want to either be more restrictive on how we're backporting, so we don't ever require backporting feature bits like that to a minor release, or think more carefully about how those feature bits are interacting, so that we can disable them too.
Are you thinking more about like the flags where we say that we require Nautilus OSDs, or the actual just like per daemon feature bits?
The actual per daemon feature bits.
Yeah.
Like the existing flags for like the major release, like require Nautilus OSDs or Luminous OSDs, that still makes sense for major release upgrades. But for keeping downgrade ability within a point release, if we did have to make some kind of protocol change that required a feature bit, like that would just be as like a separate feature bit reported by the daemons or something in the OSD map or other kind of map, perhaps.
Yeah. Yeah.
So my concern with that statement is that that's sort of the tension point where, and I don't know if we've really ever done things where the feature bit changed more than ephemeral state, but usually the reason we do that is because we need a bug fix, and the bug fix requires a protocol change, and that requires a feature bit.
I think the key would just be to, if you do have a behavior change, then try not to persist it. Like if that behavior change translates into persistent state that isn't backwards compatible, then red flag you need to figure out.
Yeah, so that would be my assumption is, but I mean, do we even need it to be like an online downgrade, or are we committing to that?
Yes, I think we need to make it online downgrades because otherwise it's essentially the same as not being able to downgrade. Like users want to be able to keep their cluster online while they're doing these upgrades, and if they encounter some kind of problem, continue keeping them online while they switch back to the old version. So
yeah, no, that makes sense.
Offline just isn't really on the table, I don't think.
I have a question. If we say we are going to start supporting downgrades, where do we start? Do we say we go back all the way to Luminous and we start testing, figure out there are bugs and start fixing them, or should we just say starting Nautilus we are going to support downgrades, or like starting Octopus we are going to do this?
I think we should start a test suite for Nautilus, see if it works, and then if it works, then
yeah. I think we need to build the test suite out before we decide what we support it on, because like it could be that like it would be weird to say, oh, we support downgrades once you're already on Nautilus 0.4 or whatever. I mean, it would work, but it would be kind of weird.
Yeah, I agree. Getting the test working is the first step. Then we can see how feasible it is.
There is one other, we talked about this briefly in the testing meeting last week, and there was one other category of things which is not on here, I don't think, which is the manager module configurations and persistent storage. I don't know if that's likely to be covered by, hopefully it would be covered by running the downgrade tests, but the upgrade ones are still pretty primitive, so I wouldn't have a lot of confidence in that.
Well, that's a good thing to write down and point out, so that we need that coverage. That's another piece of persistent storage that I guess it probably isn't covered by the object corpus test for today, for example.
Yeah, the object corpus is really good at individual like pieces, but the sort of way they're arranged on disk or like inside of like the order of the level DB keys and stuff is.
Yeah. Are there any other kind of persistent states that we aren't tracking, like similar to that wouldn't be covered by object corpus style tests?
I mean, that's the big one I'm aware of is the things that use OMAP in a defined way. So I'm not sure if you were considering that inside of the object class, but like, so RTW indexes too are also going to be the same sort of thing.
Yeah.
It'd probably make your rate of behave is going to be comparatively easy, but lots of features get backported to RGW.
Yeah, I think that one of the points I wrote down there, as maybe a common problem, is the object classes. Oftentimes they're adding new methods to object classes or changing the behavior of them. But so downgrading and expecting that same object class to still exist isn't going to work.
Well, you reverse the feature flag that enabled the usage of those features, right?
Yeah.
It's going to be part of the downgrade.
Yeah, do we actually do that in point releases very often? That's not something I've known about.
I think that's a good question for Casey. He's here.